Okay, 8.5, interpolation and extrapolation. So I'm not going to define these two words yet. I will down here. You can see they show up down here. I'm going to start by actually kind of talking about a little review of what we did last day. So remember last day we talked about linear relations, and we looked at all sorts of ways that you can express a relation. I think we said 5 different ways. I think I said 6. I even told you the mapping one, which I actually didn't go through, but I did tell you about it. And what else did we have? We had like ordered pairs, we had graph, we had table, we had in words, and we had equation. And last time what we did is I gave you some of these things and you switched it into the other ones, right? I gave you an equation and you wrote down ordered pairs and graphed it. Or I gave you a table and you wrote down ordered pairs and wrote the equation and graphed it, or whatever. I'm confusing myself. But we interchange between here. So we're going to do another one of those things to start here. This time what we're going to do is we're going to start with the graph, and then you're going to switch to the equation. Okay, first of all, actually what you're going to do is you're going to switch to the table first, and then from the table you'll go to the equation after that. So here's an example. Consider the graph of this linear relation. You know how you know it's a linear relation? Because the graph is a line. Alright, so what do we got here? We got a number of games rented. So, someone's going and renting games for their PS4 or whatever. I can't even pretend I understand those things. I don't know anything about gaming. And then we have total cost here. I feel embarrassed. I know I've made a fool of myself by saying PS4. And then we have the total cost here. And the first thing they want us to do is to make a table of values for the relation. Okay, well, where we want to look to do that is we want to look at some of the points. I can see 1 point here, 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 and 1 point here. Those are exact points. There's 6 of them. Hey, look what I did. I made a table with 6 spots. So that's what we're going to do. How are we going to do this? We're going to name all these points. So if you name this ordered pair right here, what point is that? Well, you start here. You don't move anywhere in the x direction. So x is 0. And then your y value is 20. There you go. Of course, we could also do as an ordered pair, right? 0, 20. But they want us to do a table of values, so I'm going to do it this way. The next point, this one right here, that has an x value. You're moving over 5, so that's your x. You're moving over it. Remember, this is your x here, and this is your y-axis here. So I moved over 5 for this point, and I moved up. I guess that's right between 20 and 40. It must be 30. There's my second ordered pair if you want, 530. Don't worry, I'm not going to write this for all of them. Or in the table, just 530 like that. Okay, faster now. This one here, we're from over 10 in the x direction and up 40 in the y direction. 10, 40. Next one's this one. Over 15 in the x direction and up here, I think it's supposed to be right in the middle again. It's supposed to be 50. Next one. 20, we came 20 over in the x and it goes up to 60, so it's 20, 60. I mean, you can see there's a pattern here, right? 0, 5, 10, 15, 20 must be 25. Let's see. Yep, it's at 25. And 20, 30, 40, 50, 60 must be 70. Is it? Yep, it's right between 60 and 80. It's at 70. So that's our table of values. Next thing we want to do is we want to get an equation for this. So you want to get some equation that says y equals something or other, blah, 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 blah. And you're going to have an x in it. Okay, now this is difficult because the reason this is difficult, and I think you had some in your homework that were like this. I should have explained it before. It goes up by 5 every time, right? So remember when we did these before, I told you to look at how much does it go up by? It goes up by 10, and it goes up by 10. Goes up by 10, goes up by 10, goes up by 10. Oh, you're repeatedly adding 10. So you might think that your equation starts with 10 times, remember repeatedly adding is the same as multiplying, 10 times x. You might think that. It's actually not correct. Why not? Because this isn't going up by 1, this is going up by 5, and going up by 5, and it going up by 5, and it's going up by 5. Okay, now let's think about this. if it's going up 10 every time this goes up 5, how much would the y go up if this just went up 1? If we went from 0 to 1, how much must it go up by? It must go up by 2. If that was confusing to you, you could do this. You could take this number and divide it by this number, and that'll tell you what the change is for every 1 you go up. So 10 divided by 5 is 2. So in fact, it's not going to be 10x, even though it goes 10, 10, 10, 10. Because this one went up by 5, you got to go 10 divided by 5. You get 2x. 2x here. Okay, now let's see if that worked. When we put a 2 in there, does everything work out or not? So let's try the first one here, because having 0 is beautiful. If I put 0 into the x, I get 2 times 0, which is 0. But I want 20. How do I get from 0 to 20? I add 20. Okay, let's see if that works for the next one. If I put 5 into this x right here, I go 2 times 5, which is 10, and then I add 20, I get 30. So that looks good. Let's try the next one. If I put 10 in there, 2 times 10 is 20, plus another 20 is 40. I think they're all going to work, but I'll try one more. Let's put 15 in here. 2 times 15 is 30, plus 20 is 50. I can't stop. Put 20 in there. 2 times 20 is 40, plus 20 is 60. Put 25 in there. 2 times 25 is 50, plus 20 is 70. They all work. We now have an equation that describes the graph. The equation is the most powerful thing, right? Once you have the equation, it's really easy now to figure out anything. If I asked you when x is 100, you just plug 100 in there. If I asked you if x is 5,000, put 5,000 in there. If I asked you when y is 5,000, put 5,000 in the y and then solve by using algebra. Okay, so we love, at least I love, getting the equation, because then any other work is going to be easy after that, or easier, I guess. All right, interpolation and extrapolation. They're very similar, but a little different. Interpolation is when you want to find a value by calculation or estimation between two already known values. So I know that's confusing, but let me explain. Let's say that you had this exact graph right here, and they have these points, the 5, the 10, the 15, the 20, the 25, all those, and then they join them with a line, right? Because it's a linear relation. But what if I wanted to know how much it costs to rent 8 games? There's no dot at 8, right? If I go up from the 8, there's no dot there. But come on, we can estimate, right? If I go up to the 8 and then go over from there, it ends up around there. So I don't know, what's that? Around 35 or something would be a good estimate? Or even better, once you have the formula, this formula right here, you just plug into there. So if I want to know when x is, if x is 8, the number of games is 8, I just put 8 in here. 2 times 8 is 16, plus 20 is 36. Oh, my estimate was 35 when I looked at the graph. It's 36 when I use the actual formula. So that's what they mean by interpolation. Using your graph to estimate points that aren't actually on the graph yet, or using your equation to figure it out. Now, extrapolation is very similar, except it's used to estimate values that lie beyond all the values we already know. So for example, in the points that are on this graph, let me get rid of this one because that wasn't actually on the graph. It only went up to 25 games. But what if we wanted to know how much 35 games was? Okay, we could estimate. It's not easy to do because we might have to, this would go to here. This might need to be extended a little bit, straight line, right? And then we could do our estimate from there. If I want to know 35, I would go up to the line and then over from there. And I don't know, I estimate right around $90, I guess. Okay, here's the problem with extrapolation. Sometimes linear relations don't continue. Sometimes in real life, things go like this. Straight line, straight line, straight line, straight line, and then it just kind of tails off or even drops down. Okay? I'm not saying that would happen with this relation, but some relations that does happen. So extrapolation is not as accurate. You'll notice with interpolation, it says calculation or estimation. If you use the graph, it's estimation pretty much. If you use the formula, it's calculation. But with extrapolation, it's always an estimation because we don't know whether the graph actually tails off or shoots upwards even faster. We don't know what happens. We can only assume it continues on the same relation that it was originally. Alright, so let's do some interpolation and extrapolation for the question we just did. How much would it cost to rent 50 games? 50 games. Well, if you look, 50 is well beyond the points we knew. So this is extrapolation, isn't it? It's beyond 25, so it's extrapolation. So I could put my graph going all the way up to 50. It's going to be way out here somewhere, and I could draw a straight line and then estimate from that, and then that's above the line here. You know, it's a bit of a mess. This is why extrapolation can be a real hassle. So why don't we, instead of doing that, why don't we use our equation right here? We want to know how much it's going to be for 50 games, so I'm going to put 50 into the x. So I'm going to have y equals 2 times 50 plus 20. Let me write that down. Y equals 2 times 50 plus 20. Well, 2 times 50 is 100 plus the extra 20. It's going to cost $120 to rent 50 games. Holy smokes. But who's renting 50 games? That seems a bit unrealistic. Okay, how much does it cost to rent 16 games? Well, 16, that is within our graph here, right? 16 lies right around here. If I go straight up from there and then over, it looks like it's just going to be a little bit more than 50. Maybe 51, 52. That's a good estimate. If you want to really calculate it, you could put 16 into here. Why don't we do that? Y equals 2 times 16 plus 20. Y equals 2 times 16 plus 20. 2 times 16 is 32. Add on the 20, you get $52. Is that what I estimated? I actually can't remember. Did I say 51, 52? I think I might have. All right, one more example just so you get the sense. Here's another linear relation. Linear because it's a straight line. This time we're looking at how fast a plant grows over 10 days, or 8 days. It actually goes only up to 8. So over 8 days, it's got linear growth. At time 0, what's that mean? That's the starting time. It was 1 centimeter high, and then you can see the different heights as we go along here. By the way, it doesn't have all the tick marks, but you can see there'd be a 1 here, there'd be a 3 here, right, matching up to these points here. There'd be a 5 matching up to that point. There'd be a 7 matching up to that point, and that's it. All right, so the first question, how tall would the plant be after 5.5 days? First question I have for you, is that interpolation or extrapolation? Well, 5.5 days is right here. That's within the points we know. We know from 0 to 8. So anything within 0 and 8 is interpolation. So interpolation. All right, we're going to estimate 5.5. 5.5 is right there. So we go straight up from there. I'm actually going to draw a line straight up from there until it hits the graph. And then I'm going to go straight over to the left after that. And I get it right there. So how much is that? I don't know. I guess 7 would be right here. So it looks halfway between 6 and 7. I'll call it 6.5 centimeters, I think is what I'm going to call that. Okay, last one. How tall would the plant be after 80 days? 80 days? Oh my gosh, this only goes up to 8. Well, guess what this is? This is extrapolation. This is going to be really hard to do, right? Unless you draw a graph that goes way over to 80 and you extend this line and everything. It's just crazy. I don't want to do that. So you know what we're going to have to do? We're going to have to get an equation for this. How are we going to do this? We're going to make a table of values. I know it's kind of a drag. We were so close to being done, and now suddenly I'm asking you to do this. But we can do this really fast, I promise you. Because look, the points go up 0, 1, 2, 3, 4. Oh, good. It's one of these ones where it goes up by 1. This will be way easier than the last one. At 0, it was at 1. At 1, it was at 2. At 2, it's at 3. I think we see the pattern. At 3, it's at 4. And at 4, it's at 5. That's enough. Let's stop right there. So this is beautiful. Because this is going up by 1, we can use that method we used originally when I first taught this to you. This goes up by 1, up by 1, up by 1, up by 1. Oh, so it's going to be 1, y equals 1 times x, or just x. What do you still have to do? If I put 0 in there, it doesn't equal 1, it equals 0. I still have to add 1, right? If I put 1 in there, I still have to add 1 to get 2. If I put 2 in there, I still have to add 1. I mean, another way, if you just look at it, look at all the y's. They're 1 more than the x. 0, 1, 1, 2, 2, 3, 3, 4, 4, 5. So this is our equation right here. Great, now that I have that, it's going to be very easy to figure out how tall it would be after 80 days. I just take 80 and plug it into the x. So I get y equals 80 plus 1. Well, 80 plus 1 is 81 centimeters. Done. But I want you to think about that answer for a second.
How confident do you feel about that answer? I don't feel confident at all. I mean, it is what I would guess, but I would also say I really don't think that the plant is going to continue growing higher and higher and higher and higher and higher and higher and higher for all time. There's going to come a point where this thing is going to stop growing, right? That's what happens to human beings and trees and plants, and we all stop growing at some point. So this is why extrapolation is prone to error, because we don't know what happens beyond the information that we already have.
And there you go. So, two fancy words, interpolation, extrapolation, and hopefully you now understand the difference between them. Good luck to you. Bye.